Hey, welcome back.
Hey.
We're on, what module are we on? 6? 6 of 6?
Last one of the day.
That should wrap it up. All right. This topic is advanced topics. So obviously it's kind of a catch-all. There are a number of things that we wanted to talk about, and they're kind of all encapsulated in advanced topics. So we're going to throw a few things in here, and actually Michael's going to start us off with exception handling, extremely important topic in writing any app.
Did you notice how he said we're going to throw a few things in there? Yeah, I caught that pun. So yeah, it was suddenly decided that I was the most qualified person to talk about all the errors that happened because apparently they happened to me the most. So that's fine. I'll go ahead and go with that. Let's dive into what we're going to be doing with our module. And it's going to start off, of course, with handling exceptions. And then we're going to get into a whole bunch of other cool things that Jeremy's going to get into greater detail. But with regard to all this error handling stuff, I would like to look at it this way. When we're talking about handling exceptions, we're talking about managing failures in code, and we're also talking about minimizing those failures in code. So managing them is different than minimizing them. I'd like to do both. I'd like to talk about both. So the first one would be how you could manage them, because this is not really minimizing them, it's just managing them. And you may be familiar with this type of syntax, but here it is. It's a try, catch, finally block, of which the finally, of course, is optional. And in fact, based on how you're using it, some of these things are out. Even the catch could be optional with just a finally block. But the typical use would be at least a try and a catch and possibly a finally block. The main ingredient here is that when you are looking at your try, the first thing you want to do is you're saying, okay, well, what are the suspicious lines of code? And when we say suspicious lines of code, what we mean is something that could potentially cause a problem. This could be a custom error that's thrown from an API. It could be maybe you're trying to go across the network or something and grab something through a call. You don't know if it's going to succeed or fail. So there's a number of reasons why something could be suspicious about, I don't trust that this is going to work, which is different than a syntax error. So for example, if I had a syntax error in that try, like var, V-A-R-R, in there, and I misspelled it, well, we're going to more than likely you're going to get that one caught immediately in the parsing engine itself. So the try is going to actually catch things that would be thrown as a runtime as opposed to like a syntax error. And so just keep those two in mind. Syntax, you're going to have it caught right away. Usually, like for example, in Visual Studio, it's going to report it immediately the moment you try to run it. If it's a syntax error like VARR, which is not a keyword. But it's not going to know at design time or when you're attempting to run it if the line of code will succeed in going grabbing that data or whatever the case is, or if you're going to misuse the data in some way. So going back to the try, catch, finally, that's what we mean by line or lines of suspicious code. When we catch, the ERR I have in this example is just a name I provided. You can call it whatever you want. A lot of times I see E there. Sometimes I see EX. I don't know. What do you see there?
I see E a lot. I like to use E because it means either error or exception.
Sure. That's good. And then the classic properties, I just put them in comments right there, you know, from description, message, name, number, and stack. You could access any one of those to get some further information on it. Message is probably the most popular one because it kind of gives that robust, here's what happened. But then there's a couple other ones there that can give you some more detailed information, especially about how or where it was thrown. The finally means whether we succeed or fail. So whether we ended up in the catch or completed the try successfully, we're going to call the finally block, no matter what. So that's a nice little safety net there to do some last minute, whatever you need to do in the finally. Now, the other thing you can do is throw an error. And there's multiple ways to do this. In fact, you're going to see another way in a demo in just a moment. But in this example called throw helper, it's a horrible helper, by the way, because the only thing it does is it throws an error. So it's a lousy helper. But it is helping me to, with no pun intended on the word helping, to showcase that one of the reasons why you would throw an error is because you are creating an API, even if you're the consumer of that API. So a helper function nested somewhere How is it going to report if you misused it? Well, one way is by throwing an error. You could throw an error the classic JavaScript way by providing an error number and the description. And you'll see another way to do it within the Windows 8 world in just a moment. So elsewhere in the code, if I try to use this throw helper and I put it in a try-catch block as I'm doing down below, then what that means is I will have the ability to catch it. So this is what it's going to do. It's going to say, all right, let's go ahead and grab a consolidated message by concatenating whatever the number was, as well as the message, and then we'll log it somewhere. So that's a classic use of what you might do inside of a catch block is notify or log somewhere what happened. So I would like to now demonstrate this, and I'm going to go into Visual Studio, and the first thing that I would like to highlight is the other way that you could throw an error. The Win.js, which is an API that's available for us as developers in JavaScript, it gives us this error from name, which means instead of us thinking in terms of error numbers, why not just give a categorical type of a name to it, and then you can also pass in whatever your message is. So error from name is a nice way to do this, and basically underneath the hood it is a JavaScript error. It's a nice little API to make that easy, and of course it returns an error object that can be queried for all the things we've already talked about so far. But I think the other benefit of talking about this function, which is called isTypeOf, and this is again in CodeShow, it allows us to say we want to know if the first object that's being passed in is of a certain type. And the type is going to be passed in as a string. Now, one of the things that we need to do anytime we're in JavaScript, and Jeremy, you mentioned this earlier in the day. You're like, one of the advantages we have when we're in a strongly typed language is that there's some worries that we don't worry about. If we're saying, hey, this was assigned as a string, we know it's going to be a string. Strongly typed. Weakly typed, not the case.
Right.
So sometimes in our code, what we want to do is we want to say, well, what are you? I want to know what you really are. And there's a few ways that you can query that. I created this helper function that was called isTypeOf because I wanted to say, I want to have an exact way to know exactly what this is for sure. But I wanted to be careful not to inadvertently cause errors in this typeof function. So if we look at the code, I think this is really important to see, especially if you're relatively new to JavaScript. This line can look a little confusing. We're saying if t, now remember that's an argument that's being passed in here. If t, we're not saying it equals anything, we're just saying if t, and then we're using this double ampersand operator, which is really, it's very cool. Because what this is saying is, we're going to start here and evaluate that t to be true or not true. And it would be false if, for one, we didn't pass it in as an argument. So what if I just said isTypeOf, I passed in the O, or nothing at all? That would mean t is undefined. The default behavior here, from a Boolean perspective, is that means that this t, if we didn't pass it in, would be undefined, and therefore it would evaluate to a false. If you're using double ampersand operator like this, if this side of the equation is ever false, it just stops. It does nothing else. That's an advantage for us, because now we can go to, if it's true, yeah, I got a t, great. Well, now what? Well, does t have a character at or a char at on it? See, again, it's not good enough that you just pass something in. It better have one of these on it too. Well, do you know what data type just might have that particular method on it? Do you have any guesses what t might be if it has this method on it? A character at.
I'm thinking string.
I'm thinking so too. So this is keep in mind, I'm in a function called isTypeOf. Well, I can't call my own function to see if it's a string. So I'm having to do a little bit of a specific work to find out what t is. So if it has one of those, then I can move on to the next part. If this was false, it escapes out and nothing happens. So I finally get to and t character at 0. This is also kind of intriguing because what it's saying is if we made it this far, we're going to call that method and we're going to find out what's at the 0 position of that string. If there's nothing in the string, it will return a false and then nothing else will happen in that if. But if it does return a character, it evaluates to true, so we know we have a string. The reason why I'm talking about all of this, like, what might this have to do with exception handling or error handling? This is about preventing them. It's minimizing it. If we do all of our type checking correctly, like we did here in this example, it just says, hey, we have the ability to go in and make sure that t really is a string. And if it is, now we can go on to the next line, which basically gets a little geeky looking when we're dealing with prototypes and the toString. But what we're essentially doing is we're wanting to find out if we happen to have a result where the object type matches what we're passing in, and because the default here wraps this in as object with whatever the object type is, whether it's string or number. If that happens to equal, like a true equals, as Jeremy highlighted earlier, then we're going to return true or false if it doesn't equal. Otherwise, I'm going to throw an error because something wasn't right. Because if my if failed, that means that the t was required and it must be a string. You either didn't give it to me or it wasn't a string. So think about that when you are starting to write your own functions and you want those functions to behave correctly. It's important to do a lot of that checking of that particular type. And I think with regard to errors, the other thing I wanted to highlight was that there is a global error function for certain pages. We'll find this out in more detail tomorrow, what this line means, but essentially we're in a page and we're defining that it's a page, and because of that it would have an error handler in it. This is one way to actually get a global error function for if anything goes unhandled in the whole page. Now we have a little safety net here and we can log it. And ironically, I'm using the ampersand again. I'm like, hey WinJS, do you have a log method in you? And it should, but if it doesn't, then it won't execute beyond that double ampersand. But if it does, then we can safely call it. So just another example of just doing some safe calls within your code. Now, I do have, Mr. Jeremy, more on handling exceptions.
All right.
But I'm going to hold off on talking about them until maybe a little bit later in this module, because you're going to be talking about something where I can demonstrate another more advanced way of doing exception handling, but I didn't want to show everybody what it was yet.
Well, that sounds perfectly logical. So the next topic that we're going to get into is promises. Promises are one of my favorite topics. I don't know why. They're just great. The power that they give you in a Windows 8 app, and actually not just a Windows 8 app, but web apps as well. The power that they give you on the web platform is asynchronicity. The ability to call something and have it not block your UI thread, and when it's finished happening, to only then continue with some execution is really awesome. So if you're not aware of the difference between the terms asynchronicity and concurrency, there is definitely a difference. To do something concurrently means to do two things at the same time, or multiple things at the same time. But what we're talking about is getting really smart about the use of our single thread, our UI thread, and using that to the point where we don't block, but instead these sort of calls that may take some time, instead of us waiting for the call to return. So for instance, maybe we're doing a network call or maybe we're doing a database call. Instead of waiting for that call to return, let's just send it about its way and then let a function fire whenever it's done. But in the meantime, we don't block the UI thread, and instead we continue the execution for the user. So we're going to look at promises in order to cover that. Now, promises is really a multifaceted topic. You're definitely going to be using promises if you do Windows 8 development. And the reason why is because in the WinRT, which is the API on Windows that you access when you're sitting on a computer that's running Windows 8, when you as the developer access the WinRT, if a function might take more than 50 milliseconds, and notice I said it might take more than 50 milliseconds. If there's a possibility that it'll take more than 50 milliseconds, then that is an asynchronous function. The Windows team has developed that, has implemented it as an asynchronous function. So those functions, in order for you to call them, you have to call them asynchronously. You're forced to. And this is a really good paradigm, and it's really super easy to do anyway, so don't be intimidated by it. But we want to not just be consumers of promises where we're calling asynchronous functions. We want to capture this pattern and use this pattern to our benefit as well. We want to create asynchronous functions so that when the consumers of our API or even the other parts of our app are calling these functions, they're calling them in an asynchronous fashion. So we too are participating in giving the user a fast and fluid experience on the machine by not blocking their thread.
This is, for me personally, this topic, it's kind of fun that it's in this last part because this is one of those fundamentals you really need to know this topic. So
Yeah.
I would say this is the time to drink that extra energy drink, whatever it is, do what you got to do because you have to have this. It's fundamental even for a lot of the stuff we're going to do tomorrow. And I love that you address the fact that it's not just about consuming this within Windows 8. It's also about providing our own asynchronous behaviors. But even just to be a player, we're going to have to really understand some of the basics here. So I'm excited about this.
Absolutely. So don't touch that dial. All right. This is extensively implemented in CodeShow. So you've got all this code yourself. I'm going to jump right to it so that I can show you the concept. I keep wanting to touch this screen. I can't touch the screen, but I want to. There's going to be fingerprints all over it. I'm going to go to Promises. And the first section in Promises is the concept. I need you to understand what it is that a promise is doing, okay? When you call an asynchronous function, you get a promise back, and a promise is an object. Now, promises are not exclusively a Windows thing or a Microsoft thing. Promises are a JavaScript thing. They were actually defined, the general structure for the promise pattern was defined in CommonJS. And so, like other areas, I love the way that Microsoft implemented this because they said, well, let's do asynchronicity. Instead of just inventing our new thing, let's jump onto something that's already in the web community.
Sure.
So they implemented promises, and they did a really good job at it. So we get to use promises that are in the WinJS library, but it's actually a very simple implementation. You can go look at the implementation in the WinJS library. You could even make it yourself in a half an hour. It's not a difficult concept.
So if you don't mind my interrupting,
No, not a problem.
I think I'll take an opportunity to kind of use the promise as a segue to something I think we need to address with some of those that are watching right now, and that is the promise of trying to get them a code show that works. So some are concerned maybe they're downloading a code show, they're not seeing that it's working. There could be a couple of issues. So we do have a couple reminders we'd like to give you, and I'll start with one. You need to be using RTM of Windows 8.
Windows 8 RTM, that's right. Yeah, if you have Windows 8 RP, you could try to fiddle around with it and change the references and stuff and get it to work, but you might keep running into errors. If you have Windows 8 RTM, it should work. Now, when you go to, if we could just switch to my screen here, when you go to Code Show, you need to go to the Source Code tab. And if all you want to do is kind of follow along, then right here you've got all the source available to you. You can jump into the Code Show folder, and you can jump into the pages, and for instance, the one I'm looking at right now is Promises, so you can expand Promises, and you can see each of these files, and they're rendered for you with pretty printing and everything in the window, in the browser. So you can see and follow along by just doing that. If you want to download it, don't go to downloads as you might think. That's for releases. When we build Code Show as a release, for instance, it would go there. But if you just want to download the source code, then under source code, hit download, and it'll download that as a zip. Now, that downloaded solution is still going to have, because it's with Code Show, with Codeplex, you get the benefit of being able to work with source control bindings. And so you're going to have source control bindings in there. But whenever you start it up, just hit the buttons that say, ignore the fact that there are bindings, just let me in, and it'll go ahead and open the project for you. And you can have it locally. Now, if you want to attach to it by way of source control, then the benefit to that would be anytime you want, you can go right-click, get latest version, and it would get you all the latest changes that had been made. And to do that, just go to the source code, and then go to Connect, and it'll show you how to add this TFS server in your Visual Studio, and you actually have to have a Codeplex login, and it'll show you your CodePlex login right there, and you can connect to it through TFS, okay? So the TFS server through CodePlex is really awesome the way it works. It handles all your ALM, all your work items and everything. So if you guys have any questions about that, go ahead and put it in the chat window. But we've seen some questions, so I thought we'd address that.
I think that's good that we address that. Thanks.
Now, we have built up promises so much that it had better be a good show.
It's going to be a good show.
Okay, so first the concept. I want you guys to understand again what problem we're solving here. So the first problem is this. I have emulated a long sync task by just doing a while loop. Okay, so in the code, this long sync task, I'll actually show you what that looks like. We'll go to promises.js, and I'll scroll to the end, and you can see the long sync task does a while loop for a long time. It does it for as many seconds as you give it. So right now I've chosen 3 seconds for a delay. So for 3 seconds, this runs through a while loop, which blocks the main thread. It's synchronous. You can't do anything until you get to the end of that, okay? So as far as concurrency goes, this is none. This is 0 concurrency. So that's what long sync task is. Now long task async is implemented. It's the same kind of wait, but it's implemented using the set interval. So this is not a blocking thing. This is asynchronous. As soon as it calls set interval, it automatically returns. So that's one of the concurrent functionalities or the asynchronous functionalities that's given to you in JavaScript. But both of those present a problem. Here's the first problem. This task blocks the UI. When I click the Start button, after 3 seconds, it's supposed to complete this progress bar. Let's try it. Boom. Notice that my button is frozen, and I can't click back. I can't do anything. It delayed, and 3 seconds hit, and I was finally able to go back. But it froze my UI for 3 seconds. That's not a good experience. We don't want that to happen to the user ever, 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 ever. 3 seconds later, then finally, boom, it finishes. So that's a problem because we're frozen. The next one is a problem, and I'll show you why. This is the async task. Let me go ahead and click Start. It is going to take 3 seconds for this function to go, but the progress bar advances immediately. Now, the problem with that is that it's a lie. The task didn't finish. We came back from our task in an asynchronous fashion and went ahead and finished our progress bar, and our task hadn't finished yet. So we lied to the user. So both of those are a bad experience. This is not the way you want it to happen. What we do want to happen is we want to implement promises and use the async task so that it doesn't block the thread, but not do anything until that async task has completed. So watch the way this one works. I'm going to hit Start. 1, 2, 3. Now we not only get to complete this thing only after it's been completed, but all along we can get progress updates. So we've got a lot of control over what happens and when we use this promise pattern. Now you're welcome to look at the code behind these, but it might be better to go to the uses section of the promises page and look at the code behind these. This goes from the simplest to the more advanced usage of promises. The first is just consuming a promise. So this is what you're going to do when you notice in the WinRT that there is a function that takes longer than 50 milliseconds, possibly, so it's implemented as an async function and you want to call it. So the first one, if we go to the consuming a promise example, this is the code for this demo right here, consuming a promise. Let me go ahead and click Start. Boom. 3 seconds later, I get the finishing of that bar. Now let's look at how we implemented that. The first thing that we did was we got this element that contains everything regarding method 1, and then I'm using that queue function I told you about to find the button, and when the button is clicked, we are defining this function to run. Okay, so I'm using this, remember the DOM level 1 method for setting a click event? I like that method. Here's the function that I want to run whenever the user clicks the button. That starts it. When it starts, it calls the long task async with a promise. Long task async returns a promise, and I'll show you what that looks like in a second. And here's the magic, then. A promise has a then method that hangs off of it, and we can call then and pass it a function. Actually, we can pass it more than one function, but I'll explain why we would pass it more in just a second. we pass it a function which indicates this is what I want to happen whenever this promise finishes. Now, many of you have experience, it sounds like, from the chat window with jQuery, and you notice that in jQuery, a lot of the function calls that you call expect one or more functions, callback functions, for you to pass in there. Now, that is asynchronous. jQuery is implementing synchronicity that way, but this is more of a standard way of implementing asynchronicity, where instead of having to pass a lot of callbacks into a function and then possibly on the same line having to pass even more callbacks into a parent function, we can then, because you see the then function that hangs off of a promise itself returns a promise. Okay? So I can do something that might take some time, and then when it's done I can .then, and then when that thing is done I could .then again, and I could continue to do that. So this implementation does a .then and says whenever we're complete with this asynchronous promise, I want to update the progress bar to 100%. So once again, when I click on Start, I need a reset on that, don't I? Oops. When I click on Start, it should start that, and then 2, 3, complete. Okay? It doesn't do it until we're done. Now, the next example, beyond consuming a promise, is passing on a promise. That's implemented here in the code. You can take a look. Now, in this code, remember Michael showed us that we can define a function inside of a function. That's exactly what we're doing here. And I'm making this function just called my async function. I know that this is async because I'm writing the function, and I know what's going to be returned from this function. That is a promise. And I know it's going to be a promise because I'm just returning whatever it is that long task async promise returns, and it returns to me a promise. So I'm calling an asynchronous function. It's giving me a promise. I'm passing that promise on to my caller. That caller now has a hold of the promise that my embedded function call gave to me. And it can ask anytime by using the then function if that promise has finished yet, and when it does, it can run the specified function. Okay?
That's cool.
So yeah, so to complete this progress bar now, I'm doing a .then off of my async function. And to follow naming convention, I actually probably should have ended these function names with async, because that's the convention. You'll find that in the WinRT API. If it returns a promise, it ends with async. So you can always know what to expect there. So that's passing on a promise. We didn't have to do too much except know that some asynchronous call returns a promise and return that. And then we know that we ourselves are an asynchronous function. And that works just the same. 2, 3, bam. Passing on a promise.
Sweet.
Now we get a little bit more complicated. Not too much. Not too much. It's not too big of a concept to wrap your head around. We're going to create our own promise. So this means that we're going to do something. We know that it's going to take some time, and we don't want the user to do anything with the results until such time as our promise is complete. So we start out inside of our async function saying, I want to create a new Win.js promise. And in fact, this is what I'm going to return. So my new Win.js promise is expecting me to give it a function. And that function needs to have 3 parameters. C, which stands for complete, E, which stands for an errant or exceptional case, and P, which stands for progress. Now this means that inside the context of this function here, I can call those functions C, E, and P, and I have control over completing that promise, or reporting that that promise had a problem and it's in error mode, or reporting some progress on that promise. So inside my promise, inside the function that I'm passing in, I'm going to try something. I'm going to try to call, we learned the try-catch pattern, I'm going to try to call an async method, and then if this function fires, that means that the then happened. That means that our embedded asynchronous call has come back successful, and now I know that we can complete our promise. And I do that by calling the C function that was referenced here. If I wanted to throw an error case, I would call the E, and that's exactly what I do down here. So now I'm saying, if any sort of an error happens, catch that down here. And now I want to not want to throw that error to the main thread. I just want to report to this promise that there was an error inside the promise and give whoever is using that promise the opportunity to respond to the error in the way that they so choose.
Yeah.
Okay? And then, anytime I want, if, for instance, something had occurred and I know that I'm 10% done, I could then call P and I could report back in P some status about some progress that's been made in this promise. Now, this promise won't report that it's complete yet, but that event will fire that progress has happened, and I'll be able to capture that. I'll show you that code in just a minute. The last one, and let's just show that this one works exactly the same way. 2, 3, bam. And finally, a stored promise.